Hello everyone, my name is xulili. My student ID is 2022635934. Today is 2023 July 25. I'm a student of Electric Engineering Factory. This is my progress report, Semester 2, March 2023. My research divided into several parts. Part B, Supervisor. Part C, Title Research. Part D, Introduction. Part E, Status of Major Research. Part F, Gantt chart. Part G, Status of Publication. Part H, Status of thesis. Part I, Planning for next semester. Part B, Supervisor. My main supervisor is Dr. Muhammad Nobil bin Hadinat. My co-supervisor is Dr. Nick Hakmi bin K.O. Title Research. The title of my research is Fault-Tolerant Bidirectional DC-DC Converter, utilizing series parallel LLC resonant topology. Introduction. The study focused on EV charging system with bidirectional DC-DC converter and make significant contributions to this topology. Resonant network parameter design. During the operation of the converter, the design of the resonant network often affects the efficiency and working stability of the converter. Design practical and concise resonant component is the key of the system topology. Design a new DC-DC converter topology, taking the topology structure of LLC resonant converter as a research object. The traditional LLC resonant converter is analyzed firstly, and the new LLC resonant converter is studied based on the parity analysis of the basic structure and the previous research. Design parameters play an important role in achieving desired objective. This research is mainly aimed at the fault-tolerant control of bidirectional DC-DC converter. When the unit of the topology is faulty, the fault-tolerant control system automatically reconfigure the control system, ensure the proper operation of the circuit. This work uses MATLAB software to experimental simulation research. Introduction. As an important part of the renewable energy system, DC-DC converters are important energy conversion components in the field of photovoltaic power generation and new energy vehicle. The traditional converter is a boost converter, which has the advantage of simple structure and stable operation. According to whether the topology concerns a insulation transformer. The basic DC-DC converter topology can be divided into two types, non-insulated and insulated. Insulated converter has a higher safety performance, mainly including dual active for average DC-DC converter, bidirectional series resonant converters, bidirectional LLC resonant converters, etc. This research will use a bidirectional LLC resonant converter, optimize the resonant parameters on this basis, and design the resonant network parameters when the working in forward and reverse direction so as to realize bidirectional DC-DC conversion. This is the block diagram of my research direction. The orange circle is bidirectional DC-DC converter. The function of this converter is to change low voltage into high voltage charging for the EV car. Part E. Status of major research. Problem statements. Taking the fault-tolerant DC-DC resonant converter as the main research objective, the topological structure and fault-tolerant control technology of this type of inverter are focused on, and a high-efficiency and high-powered fault-tolerant converter is designed. First, the first stage includes concluding literature, discussing previous research results, and determining the overall research ideas. Second, the second stage is to analyze and improve existing converter technology model. Analyze the LLC resonance of the converter and realize the high-efficiency topology model of the zero-voltage interruption. Third, find a fault-tolerant control method suitable for the converter. Select switching tubes and other components, and monitor their voltage and current signal as a single signal input part of the fault-tolerant controller. A fault-tolerant control strategy is designed to achieve parity control when the open current fault and a short current fault occurs in the circuit, so as to ensure the efficiency and stable operation of the converter after the fault occurs as much as possible. The last stage is the simulation experiment. The analysis of experimental result and the summary of the whole research. Research objective. The DC-DC converter is a core component to realize the voltage conversion function in the switching pole supply, and it is also a key component that determines the reliability of the switch power supply. Widely used in distributed wind power generation, distributed photovoltaic power generation, energy storage system, and electric vehicle and other fields. The new converter has the characteristics of high efficiency and strong fault tolerance, which promotes the development and application of new energy. Methodology 1. Study advanced documents. Summarize and the experience and conduct theoretic study. Second, carry out gain analysis through the foundational wave equivalent method to research the gain. Second, carry out topology fault-tolerant design through the fault-tolerant method or model analysis. The last one, simulation by MATLAB software. Outcome. There will be three outcomes of my research: a fault-tolerant LLC resonant DC-DC converter. MATLAB simulation results are good. Make a hard-wave model of the converter in the laboratory. Gantt chart. This is the Gantt chart table. And now I'm in topology research. And in this semester and in the next semester, I will find the fault signals in topological circuits. Status of publication. In this semester, I have not published paper. Status of series writing. My series have finished 15% of abstract, and chapter 1 I have finished 18%. Chapter 2 literature review I have finished 18%. Chapter 3 research methodology I have finished 20%. And chapter 4 and chapter 5 I have not right now. Planning for the next semester. Next semester, I will find a new LLC resonant topology. Determination of a new topology method of LLC resonant converter by parameter conclusion and topological analysis. And fault signal in topology circuit. Reasonable truth, the converter fault signal method. And the third one, find fault-tolerant control. Design the fault-tolerant control method to realize the fault-tolerant operation of the converter. This is my progress report. Thank you for your listening.